All right, I'm going to do a quick video on statistics. So I'm going to call this stats review. All right, so this is for grade 12 essential math. So in terms of stats, you need to be comfortable and familiar with measures of central tendencies. The measures of central tendency would be the mean, median, and the mode. Okay? So the mean, median, and mode. Okay, those are the three M's. Let's start with the mean here. Mean is also known as our average. And remember, you can find the average between two numbers, and it's essentially the sum of all values divided by the number of values that you are considering. Okay? That is the formula for mean. And so for that one, you need to make sure you always include units. What do we need? What else do we need to know about the mean? It is mostly, right? It is most affected by an outlier. Okay, so if you consider all three of these, it will be mostly affected by any outliers. And remember that outliers are significantly different from the rest. Okay, that's one thing that you need to know about an outlier. So mean is mostly affected. Median is not affected by an outlier. And mode, it just depends on the scenario. Okay, if the outlier happens, if there's happen to be two or more outliers and they are also the mode, then of course if you were to remove it, we're talking about trimmed mean later on, then it might be affected. But anyways, when there's an outlier, the best option is usually a median. Okay, so not affected by outlier. Not as much as the mean, at least. So when there's an outlier, we usually want to go with the mean, and they all three of these try to find the center of your data set. Okay, that's what the main goal is, to find the middle. So we talked about that. That was the first part of statistics, and just remember, you're going to have a number of different scenarios. If you have, just a bunch of values. So let's say, I'm just going to come up with an example here real quick. Let's talk temperatures, right? So temperatures in degrees Celsius. And so you observe that over a 5-day period, you've got -2, 5, 0, -1, and 3, let's say +3. So what's the average temperature? The mean would simply be adding it all up. So when there's a negative, you just gotta put a negative in front of it. That's it. Okay, so keep the sign of the two negatives. So there's 2 days where the temperature is below 0. And then just count the number of values you're adding. Sorry, that's not 0, that's 5. Okay. And so if you do the math here, that's 3, 2, plus 3 is 5. So it's 5 divided by 5. So your average temperature is 1. Okay, 1 degree Celsius, positive in this case. So that's how you find your average. Let's go back up here just real quick. Mode is the most popular value. Okay, the one that appears most often. If there is none, right? If there is none, we just say none. We don't say 0, because then you're saying 0 is the most common value. Should I maybe give a little example here? Maybe I'll just keep it at that. Most popular value, mean is add everything up divided by the number of values. And remember, you can find the average of just two values, right? -2 plus 5 divided by 2. So that also works, and you'll see that in when you work in precision measurement, that's what you have. Okay. So mean, median, mode, we've covered it. And remember, outlier could be on the upper or on the lower end. So for example, if I had my 5-day daily highs, let's say, and you had another one here that said like plus 15 or negative 15 for that matter, it'd be very different than compared to the rest. In fact, as I'm making this video, we're coming up, we had very cold temperatures, -22, -30 something, -27, and then for 2 days it was +2 and +1. And coming from a 7-day forecast, those two plus, like the very warm temperatures, would have been considered outliers. That's not normal, especially because we're dipping right back down to very cold temperatures. So that's just when this video, close to when this video was made. So keep that in mind. All right, let's keep going here. Then we talked about trimmed mean. Okay, maybe I should do a puzzle real quick here. Puzzle, if it ever comes your way, you know it. So let's say you can only use numbers. Use 1 to 10, let's say, and you have a median. I will pause this a bit after. Let's say our median is supposed to be 7. Our mode is 9. And our average is 6, let's say. Okay, and you're supposed to fill in 5 values like this. The first one you start with is median, then your mode, and because the mode is 9, that's the one that is most should occur most often, and so you would put the 9 and the 9 there. Okay, so now that's your mode, and it's above the median because you want it arranged. And then mean supposed to be 6. So what I will do is, knowing that there are 5 values, I'll just multiply that by 5. So I'm supposed to get a sum of 30. If I add all of this up, all 5, I'm supposed to get 30 to get that average of 6. And so in this case, I got 9 and 9 is 18 plus 7 is 25. So I need this to add up to 5. And you're allowed to use 1 to 10. So you could use 2, 3, that would still work. You could use 1, 4, right? So you've got options there in that case. So either one would work there. So puzzles are good. I think I will just quickly talk about backwards when it comes to just a regular mean scenario. Okay, so let's say the mean is, let's say, 65%. That's what you want your average to be. You've got tests with the following scores. Okay, and I'll just make a little table here. Let's say you're considering 4 tests. You got 78, 52, you've got 85, and you've got 63, let's say. Okay, so those are your 4 scores, and then you're wondering on the 5th, okay, what mark do I need on that 5th test to get that average of 65? And so in that case, you simply go 65%. We can just leave the units for now, and we're going to add this up. Okay, so if we add that up, what do you get? You get 278. So this is 278 so far. And then, so that's what we're going to say. The sum so far is 278, and the 5th test will be that. And remember, we're considering 5 tests, so you'll put the 5 there. And now it's just a matter of doing some algebra there. So remember, first order of business is, let's get rid of the division there. So we'll multiply both sides by 5. That cancels or essentially gives us 1. So 5 times 65, that's 325. And you end up with 278 plus x here. And the next order of business would be to subtract both sides by 278 in order to get rid of that, because remember, you want to isolate x. And so 325 minus 278 is 47% is what is needed. It's actually, you can fail the last test in this case. Okay, it is possible, since a mark of less than 100% is needed. Okay, so that's a statement that one could make. Is it probable? Like, is it likely? Yeah, right? There's been an 85, a 78, a 63. So basically, every single score that was that we had before was above 47. So it's very, very probable, right? Likely that that's gonna work out for this person, this student. The next part is going to be trimmed mean. Okay, you need to know what it is, what a trimmed mean scenario okay. Removes the outlier since the highest and lowest values are omitted. Okay, I have to say here, it could be the 2 highest and the 2 lowest. Okay, so the question will tell you, but regardless, the outlier is going to be on one of the ends, on the outsides, either on the low end or on the high end. And so what we do is we remove one from each end, and in so doing, you get rid of the outlier. Okay, so the outliers, it is more representative of the scenario. Eliminates bias, not as skewed. Okay. However, the trimmed mean, sometimes the province will spin it and ask you, why would somebody want to use the trimmed mean? So, for example, let's have this example where we have 5 test scores, right? And so you've got, I'm going to arrange them. You've got 45, you've got 62, 75, 77, and let's say an 80. Okay. So what would be the mean in this case? The mean would just be 45 plus 62 plus 75 plus 77 plus 80 divided by 5. Okay. So what does that give us? That gives us 339. Okay, if you add that up, divided by 5, that's 67.8%. Okay, so if just the average is being used, the regular arithmetic mean. Okay, I should, now this just reminds me, let's go up here quickly. This is the arithmetic mean. The arithmetic mean is the average that you all grew up working with. Okay, so that's what this is the arithmetic mean. And so I'm just going to say again arithmetic. Okay, where you include all values. So that's one of the things, the difference between them. Okay, versus the trimmed mean. If you figure out the trimmed mean, we would, I'll just go 45, 62, 75, 77, and 80. Obviously, you could have a whole lot more values than that. But the trim, we would just get the lowest, so it may or may not be arranged. You get rid of the highest and the lowest. So the trimmed mean is just 62 plus 75 plus 77. Or you take the 339, subtract the 80, subtract the 45. But what you need to remember is that it's now divided by 3. So in fact, I'm going to do that. I'm going to go 339 minus 45 minus 80. That's 214 over 3. That is 71.33%. So in this case, you would want to use the trimmed mean, right? Because it is higher. Right? It is higher. And when the reason is because it removes, this would be in this case considered the outlier. But the question is going to tell you anyways to subtract the lowest and the highest. So in doing so, you are getting rid of the outlier, whether it's up top or in the bottom, you are getting rid of the outlier that way. But sometimes it will ask you identify the outlier. This is the outlier in this particular case. That is the outlier. It's a low outlier, right? It's right there. You got rid of it. So in this case, the student would want to go with trimmed mean because it increases your mark. However, it may be that you get an example where you have a really high mark, let's say of 99, let's say, or 95, and all of the marks that are below it are not necessarily that much lower. Okay, so it's the high mark that you want to keep. It could be that in trimming the mean that your average actually decreases. If your outlier is on the high end, it will decrease. Okay, so that's when you wouldn't want to use it. So be careful there and read the question, what is being asked. Okay, so that's trimmed mean. Pause this here real quick. Next, we deal with weighted mean. And yes, different categories have different weights in this case, so you need to consider that. I want you to think of multiply, add, then divide. Okay, that's what you want to do here. And I did break it out into two categories, so you could have percentages, or you could have a scenario where it's just nothing to do with percentages. When it's percentages, you need to check to see if something adds up to 100. So for example, percentages, here's an example. Before I say example, I'm just going to say percentages. What I want you to do is check if one column or row adds to 100%. If so, we divide by 100 for sure. Okay, that is guaranteed. So the example, you've got category, you've got the actual score, and the weight. So this is a classic one, calculate someone's final score. Let's just keep it simple here. We're just gonna have 3 categories. So we're gonna have ACs, quizzes, and tests. That's it. And when it's someone's final score, you're gonna tell that the weight is gonna be adding up to 100. Okay, so let's say the ACs are 20%, quizzes are 30, let's say that's 50 already, and tests are worth 50%. And here we can just make up what someone got. So let's say on the ACs, someone scored really high. On the quizzes, right, maybe 75 on average, and on tests, let's say 80. Okay, so we've got a bunch of percentages, but you check and you see that this is this row here, the weight column or the weight row adds up to 100. So that D part of MAD, you're going to make sure you divide it by 100. It's guaranteed. So this is where MAD comes in, right? So first you multiply. So I'm going to give that a color. So we multiply across like this, and we get our answers. So this is 1800, and you have, 1 second. You have 2250, and then 80 times 50, you've got 4,000. Okay, so that's the multiplying part. Then you have the adding part. Okay, so we add our answers. So this, obviously this chart could be much longer, and you get, if you add that all up, 8,050. So basically, to find the average here, it's going to be a weighted mean scenario. You go 80, 50, right? That's the MA part, and then we divide by 100 because we've determined that. So basically, you just divide your answer on the calculator by 100, and you get 80.5 as the average for this student. And if they ever ask which of these categories should one put most emphasis on, the answer is the test. Why? Because it's weighted the heaviest, right? So that goes without saying. That's something that you need to make sure you are aware of. It just brings me back, one thing that I missed is if we go back to the beginning of the stats review, we got to make sure that the median, we need to arrange it, okay? And so when you have to figure out the median, let's see where we can fit that in. I'm going to fit that in here. My bad. Median. We have to arrange. So if it's not arranged, then you're going to figure it out. If it's odd, right, pick middle value. So it's actually going to be a value. And so you just got to make sure there's the same amount to either side of the one you're picking. So let's go over here. There's 5 in this puzzle, right? If you think this is the median, there should be 2. There's 2 on both sides, and it's arranged, so 7 would be the median here. And same if it's even. Okay, then you add. Okay, you add the middle numbers. Add middle values, and then we divide it by 2. That's what you want to do. So let's say it had been even. I don't know if I can insert an example here. So let's say you have 1, 2, 3, 5, 7. So we've got 5 here, and one more value, 8. So there's an even number of values. You think it's 3 and 5 covered up. You should still have 2 to either side. So you're going to have to consider these two. 3 plus 5 divided by 2. That's 8 divided by 2. Your median is 4 units. And remember, there will be units attached to this, most likely. Okay. So there's your one example for the median. I should have thought of that earlier. But remember, this is just a bit of a crash course to review what we've already done. Okay. Next, I'm just going to give you a quick example here of how percentages could show up. So this is straight from our notes on page 40 if you're going back to your notes. So here we had a scenario where we had percentages and a row with just regular values, right? So again, calculate the mean number of devices per household. So you multiply, right, MAD. So you go multiply, and then we added everything. And we realized that one of the rows added up to 100%. So we just go ahead and our final is divided by 100, and then you get your answer that way. In this case, it was 5.58 devices. Another thing I want to say here is to do your unit analysis, so especially this one. When you multiply, when you do the MA part, you always ask yourself, what are you multiplying? In this case, it was devices times percent every single time, okay? So that's what's happening on the top throughout. Those would be the units that we attach to it. Then you ask yourself, what do you want to remain? In this case, it says calculate the mean number of devices. You want that to stay. So we need to cancel out percentages, which means you need to go and add up the row of percentages, which we knew was 100, okay? But regardless, this just confirms that in order to cancel out percentages and just be left with devices. So that's another way to know whether or not you're doing things right. Okay, I'm gonna give you another example here. This is the weighted mean scenario. What if you have a backwards weighted mean? Okay, backwards weighted. So let's take that exact example there. Category, ACs, quiz, and test. And we'll score, weight. So this might, I'm taking up more space than, but let's say you know that ACs, it's 90-20, we're going to copy this one. But we're wondering, what do we need to score on the test, which is worth 50% in terms of its weight? What do we need to get there to get, we want a mean of, let's say, 90% overall. How do we get that? So again, you do the math part, right? So this is 1800, this is 2250, and this we don't know, so we're gonna call that x, right? So that's 50x in a sense. We want the mean to be 90, so we know this number right here. So this is 90 is equal to, let's do the adding part. And we know we have to divide by 100, especially if it's a test scenario. And we also know that this adds up to 100. And so now we're going to clean it up a little bit. So 90 is equal to, so let's add up 1800 plus 2250. That's 4050 plus 50x over 100. And then it's just opposite operations here. Cancel those. You get 9,000 on that side. And then you have 4050 plus 50x. We subtract 4050 from both sides. Okay, that cancels out there. So you end up with negative 4950 on this. Sorry, not negative. Just 4950. And on this side, you end up with 50x. Now we divide both sides by 50. And you get 99%. So that's what you need to get on your test. Sorry, you can't see that. There you go. Divide by 50. You need 99%. So it is possible because it's still less than 100 that you need. So even 100 would still be possible. So weighted mean there. Okay. Then we're going to have another weighted mean without percentages. Let's try one. I'm just going to make one up here. So let's just say hours of sleep and number of students. Okay, so let's say that 5 hours of sleep, and there's 12 students, 7 hours of sleep, or there's going to be 9 students that said they sleep 7 hours. We've got 5 that say they sleep 8 hours, and that's it. And you're asked to find the average hours of sleep. Okay, that's what this question is asking you for. So you right away, you're like, okay, there's 2 different categories, 2 different columns, and it's asking for average. So you do the same as before. Okay, so you will use the steps for MAD. So you first multiply across between categories, not within. Okay, so this is 60, this is 63, and this is 40. Okay, you add these up, that's the A part, so that's 123, 163. Okay, so to find your average, you know it's going to be 163, but now it's the tricky part. What do we divide by? What do we divide by? So this is where you do your unit analysis. What were you multiplying the whole time? You're multiplying hours of sleep times students. Okay? So now you ask yourself, what is the question asking? It's asking for average hours of sleep, right? Average hours of sleep. So you want hours to stay, therefore you have to divide by the sum of all students. Okay? So we add this up, so we got 12 and 9, that's 21, and 5 is 26. So we're going to put the 26 here, and it's 163 divided by 26, and that's 6.27 hours of sleep on average that a student gets in this particular scenario. Okay. So that's a weighted mean without percentages. Okay. All right. We still have to talk about the percentile rank concept. Okay, it's very important. I'm going on 33 minutes already, but it is important, so I want you to continue writing this down, paying attention. So here we go, percentile rank. Percentile rank, okay, tells us the percentage of values that are below a certain score. And the score, you can, like, it could be anything. It could be weight, height, actual test score. It doesn't matter. But that's what percentile rank tells us. Okay? So the formula is going to be B divided by N times 100. Okay? Where B stands for number of values below the score that you're considering, and N is the total number of values. This, in my opinion, is absolutely, I mean, it's on your formula sheet, but I think it doesn't lay it out as nicely. On no percentages, whole number. This is, if you don't want to, you can lose a lot of marks if you don't have that on there. So make sure, no percentages, no whole numbers to the answer of this, which is counterintuitive because you multiply by 100, you've been told the whole time do it, but no, you're ranking, okay? So, example, if your test score places you in the 60th percentile, what does that mean? It means that 60% of students scored less than you. It doesn't tell you what your actual score is. You could have actually failed and just a bunch of students also, just 60%, actually more than half of the class scored below you, okay? So let's do an example here. So just so you know, PR 60 is the same thing as 60th percentile, so just another way of writing it. So let me give you an example here. It varies so much. It is all over the place, right? But if you have, for example, a player's heights, and I'm going to arrange this. So 160 centimeters, 163, 170, 172, 177, 182, 190, and 196, let's say. 8, there's 8 values here. Okay? How do you find the percentile rank? A percentile rank of a height of, let's say, 172. That's this one right here. 172. So what you do is, to figure out the percentile rank, first of all, you know that there's 1, 2, 3, 4, 5, 6, 7, 8. In this case, you don't have to add because these are just like 8 different players, let's say. 172 is right here, so in this case, it's quite easy to identify that this is B. Not in terms of, don't add them up, okay? Read the question carefully. There's 3, okay? 3 values or 3 players that are shorter than 172. So you're ranking what this height, how does that compare to everybody else? So we just go 3 divided by 8 times 100, and here it is, 37.5. You can't have that. So you got to either go 38 or 37. Okay. Don't do both, right? You decide which one. No percentage, nothing. So PR is 38th percentile. What does that mean? That in this case, 38% of players are shorter. That's what that means. Okay. Let's do another example. Let's talk about the amount of snowfall. Okay, so let's start in November. November, December, January, February, March. So let's say it stops after that. April often could still have, so let's add that. What about this? I'm just making this up, right, to help you out. So let's say in November we had 20 centimeters. December we had 25 centimeters. January we had 18 centimeters. February we had 32 centimeters. We got a big storm. And March we had 22 centimeters. April, 5 centimeters in total. Okay. So the question could ask, calculate the percentile rank for a snowfall of, let's say, 20 centimeters. It could have said that, or it could have said for the snowfall of the month of November. So you got to be somewhat careful. It really doesn't matter. What you do know is this. Don't add these up. Don't be saying, oh, the total is this. No, no, no. How many months are we considering here? 1, 2, 3, 4, 5, 6. Right? How many would be having less than 20 centimeters? It can't count itself, right? It's not less anyways. Not less. This one is less. And this one. There's only 2 months, right, that have less snowfall. So this would be 2 divided by 6, which is 33.33. Can't have that, right? So you're just going to say 33rd or 34th. Or don't even have the RD there. Just have a whole number. Okay. So there we have. That's percentile rank in a nutshell. Refrain. I mean, could you have adding up? For sure. Okay. Sorry about that. You could also, I've seen this before, and you've seen this in my notes, that you might have different bars. This would be the 50th percentile in the middle. And then just random markings on there, where let's say screen time, 7 hours of screen time here, 4 hours, 1 hour, and it's just random, right? These could be anything. 11 hours, and you know that this is the 90th percentile, this is the 80th, this puts you at the 30th, and this is 10th percentile. Okay, so you got to be able to read this a little bit. So a screen time of 7 hours would put you in the 50th percentile. So this is percentile rank, which means 50% of people that participated in the survey have less than 7 hours of screen time. Right? A 4-hour screen time puts you in the 30th percentile, which means 30% of people spend less than that. But what if they said between 4 and 7? What percentage is in between? You should be able to see that it's 20% in between. Okay? Here, there's a 30% in between. Okay? Just by looking at these values. So sometimes they've done that. Just be careful there. Be wise about it. And remember, percentile rank is all about ranking you. Okay? So if you have a high percentile rank in terms of, for example, your test score, that means that you did better than a lot or most. But it doesn't necessarily mean that you did very well on the test. It doesn't necessarily. Okay. Okay. All right. This is everything for statistics. Hope that helps.